Et bonjour à tous et merci d'avoir lâché vos volants. Et aujourd'hui, une vidéo très spéciale, peut-être la vidéo la plus spéciale que j'ai jamais faite sur la chaîne. Un sujet que j'avais envie de couvrir depuis longtemps et j'ai voyagé jusqu'en Finlande pour en parler. Oui, ça fait longtemps que j'avais envie de parler de direct drive, de tous ces mots techniques, de couple, de slew, de cogging, d'encodeur, de filtres. Mais c'est pas évident, c'est quand même très technique, je suis pas un ingénieur, j'allais probablement dire des bêtises, et donc qui mieux que Simucube pour nous parler, pour nous démystifier un peu tout ça, nous expliquer tous les termes, et qui mieux en plus que le patron, enfin le fondateur, le cofondateur de Simucube, Tero, vous allez voir, il a été super sympa, il m'a accordé pas mal de temps, donc prenez-vous un bon café, ou plutôt une bonne bière, enfin vous choisissez. Pensez à activer les sous-titres parce que forcément l'interview va être en anglais, mais j'ai vérifié les sous-titres automatiques de Google fonctionnent franchement très bien, il manque pas grand-chose, donc vous allez pouvoir tout comprendre. Et puis dites-moi en commentaire si vous avez apprécié ce format et puis bon visionnage. Ciao. Hello and thanks for dropping your wheel. Today we have a very special video. I flew to Finland to meet you. To meet at Simucube headquarters. Thank you so much, Tero. First, let's introduce you. Who are you?
Yes. So now my name is Tero Kontkanen and I'm the co-founder of this company and I work here as a CTO and also I do lots of product management and strategic things.
Okay, so thank you for having some time for us. I take the opportunity of being in there to have this chat with you because we see a lot of discussion about direct drive technology. It has been a revolution for the past years, but there is a lot of technical terms, technical information. Some are not so easy to understand. I think there are some misconception maybe in the community. I wanted to make this kind of video for quite a long time, but I didn't feel technical enough and who better than you to tell us what's right and what's wrong?
Yes, I can definitely answer your questions. I have been also developing this very Simucube 2 product and Simucube 1 also, because when the company was smaller, I was also a developer and I designed the electronics and software in there.
Okay, so let's start before going into nerd details. Let's talk about direct drive in general. What is your vision about direct drive? Direct drive, why has it been such a game changer for the hobby, for the industry?
The main thing in direct drive is that there's just a motor, encoder and controller, and there's no gearbox or belt transmission after the motor and between the wheel, because the transmission makes it, it adds friction, it adds flexibility, it adds some roughness and
Time response, maybe?
Yeah, and it's also slower because in older wheelbases there was a reduction gear. So the motor spin many times and the wheel will turn slower and the motor speed will actually then limit how fast it can respond.
Okay.
And also the force feedback is weaker because the sensors for torque control is in the motor and not in the wheel.
Okay.
So it kind of adds extra layer of disturbance to have the gear between the motor and wheel.
So how does it translate for the end user, for the driver? What does it change compared to before?
The main thing I would say is transparency. In ideal case, simulator is like a clear window to the physics of the simulation. And this direct drive just eliminates one stain in the window. It's kind of more clear, more pure, transparent. It just gives what the game wants to you feel.
Okay.
But the transmission would kind of add extra
filters.
Like a distortion.
Okay.
Rather. It's not like a filter that anybody wants. It's a distortion. Many kind of unideal
And for you, as an engineer, as a tech guy, what does it open new window of opportunity, let's say, in terms of improving, push the boundaries, maybe?
Yeah, definitely. Direct drive has revolutionized the whole sim racing market, and for good reason.
Yeah,
because it's just a superior technology. And reason why it wasn't before direct drive was actually the big motor it needed. Direct drive needs big and heavy motor, and the older wheelbases just used a small motor that was cheap, very cheap to make. But nowadays,
heavy-duty motors.
Yeah, heavy-duty motors. These are used in industrial automation and robotics, and it was uncommon in consumer products to use this kind of heavy metal motors. But nowadays, it's the way to go.
You make it possible for everybody to have this motor. Okay.
Yeah, so it was basically cost why it was not direct drive in the first place. But now we just appreciate the direct drive so much that the cost is
where we want
secondary.
more. Okay, so let's now start to dive, because we have many technical terms, but the first one that came up in marketing documents, in all the communication by the brands, and also as a main criteria, the first criteria when we want to choose a base is the torque, is the power. What's your vision about that? What is the correct number? We see a lot of information. Some people say 8 is enough. Some people say 15 is a sweet spot. What is your vision about that?
It's choice of the racer. It's just a torque level says how much is the maximum torque that you can produce. The older non-direct drive wheels, they have like 5 Newton meters or something like that, and it was quite weak. And the highest torque levels in market are more like 30 Newton meters, and that's a lot. It depends on the racer. Some racers like to have a lot of torque available because they can turn on the torque. They can get the details more pronounced. When you have more torque, you can feel every road texture much clearer.
So it's more details than just power for power.
Yeah. You mean when you have a low torque, you can miss the details. Okay. When you have a higher torque, you can feel the road and the car much better.
Okay, so maybe we are talking about clipping?
Yeah, clipping is another thing that happens when the torque runs out. So if the simulator wants you to have a certain torque and the motor has limited torque, then you have a clipping, which means that this torque just gets
you only have resistance but no more details.
Yeah, I can draw a picture like, so here we have a 0 torque, and this is, for example, what game wants to have. And this axis is time. Time goes forward, 0 is here, and let's say 10 Newton meters here and minus 10 here. So this is what game wants, but if the motor has limit here, the clipping happens. It does that. Also in the negative side, it clips here, and you will not feel these details at all. You will miss some parts. You will get only this area that is possible to produce with the wheelbase, and that's clipping. Clipping means that it cuts to the...
So when you are here, you still have the resistance of the steering, but you lose all the details, information of the road texture.
Exactly, yes.
Okay.
So you won't feel any details that are there. So it kind of feels like a static torque, and it feels like quite weird. Actually, it feels like a distortion. You will suddenly lose the details, and below this certain clipping level, you will get the
Okay,
details
so
back.
so that's where power, when you reach out this limit, when you need personally more power.
Yeah, about this, talking about correct level, you should definitely have a wheelbase that will not clip
Okay.
the signal too early. So I would rather have a clipping level beyond what you
Yeah.
actually need.
Some room
Yeah, headroom.
Headroom.
Yeah, headroom there.
to get more details. But
Yeah.
also there is this saying that more powerful motor, more powerful base on top of this clipping issue also give you more responsiveness, more velocity. Right? Is it true or not anymore?
Sometimes, yes. It depends. There are many characteristics of. There's more than torque. There's maximum velocity, or actually, I can draw a picture there. And there's a slew rate also. I will
Okay.
explain each one. So this is torque, what we explained, and the clipping. And then we have a how fast the motor can produce the torque when it's spinning. And it's called torque versus velocity. We can draw another picture here. Again, here is a torque on this axis and velocity or RPM on this axis. So in motors, electric motors, this goes like that. When the speed increases, the torque stays constant until it starts to fall down. And different motors have different torque versus speed curves. Some motors have it like this, and some earlier will stop producing the torque. And this will feel when if this is too low, like you want to have torque here, it's not possible with this motor.
Okay.
So there are differences in different motors, and higher power motor
Usually
has
tend to go higher.
Yeah, exactly.
Okay.
And this actually also need higher power supply power. And this is actually why, for example, this Simucube 2 Ultimate has very high power supply, so we can extend this
Okay.
as far as possible.
Okay, thank you. That's very clear. That brings me to how it translates to marketing. We see brands, most of the brands, they communicate on peak. Some, I will not drop names, but everybody knows, they are talking about consistent torque. Is it really something about that? Or because as you show in the game drawing of the torque, what the games requires, by definition, it's peak. So is it really something technical, or is just a marketing way of tricking people, saying like, okay, you buy a 15 Newton meter, but it's consistent, so it's actually more. Is it something true, or just?
Yeah, there's time for another picture about this peak torque and continuous torque. I will draw a picture of what happens. For example, we have a signal. The game sends you some signal again. This is the desired torque that the game wants. And everything's fine as long as motor can produce this. It will follow the curve. But at some point, motor might kind of get limited. It can, for example, run out of power or overheat, or it needs to reduce or throttle the torque. And what happens then, if it happens, the motor kind of starts to reduce the torque. You don't get what the game wants anymore. So it's kind of, you start to lose the torque while driving if the peak torque is lost and it goes back to the sustainable torque level that the motor can continuously produce.
But in your experience, any brands who communicate on peak, they can hold, or they actually drop?
That's at some point they will drop, but this is normal.
In real life, I mean, not in terms of extreme testing just to push the boundaries of the but for every normal sim racer. Is it? I never experienced. I drove many bases, and I never experienced a moment where I felt like something is wrong and it's dropping. I did not experience that. So
it's if the wheelbase is designed well, it doesn't happen in normal racing. But this is not specified usually in wheelbases how long it can produce the torque, because if the wheelbase is too weak or the peak torque, the duration is too short, it will kind of start clipping or reducing torque during normal racing. But if the peak torque specification is good enough, it can kind of go through this normal game uses, and you will not get any.
But this
drawbacks.
is not something the brands will communicate, so we don't have any way to.
Yeah, there is no clear communication on that, how much it can produce. But definitely there are differences. Typically, if the power supply is small or the motor is small, it tends to kind of have less stamina to continue the torque level over long times. And of course, this depends on how much of the torque you are using. If you are using like 50% of the torque, you will set the torque level.
Will never drop.
It will likely to be fine. But if you are running at 100% torque levels, then you are more likely to get this reduction of torque.
To conclude on this torque topic, what's your opinion? If I have deep pocket, but I'm a new sim racer, should I go directly to the top range, or should I, like cars, you don't learn to drive on a Porsche. You start with a city car, and step by step you get older, more experience, and you step up. There is probably not a universal answer, but what's your opinion about that? Should you go step by step to feel to enjoy each step up, or you should go directly to the top range?
It depends. I would probably not take the maximum torque models right away, because you might not need them. Some extreme users need them, like motorsport trainers probably want this most high torque model to kind of replicate the real car. But I would say that I would not take the lowest torque models, at least for myself, because I probably might be disappointed at some point, because also my strength will improve when I'm driving. Muscles get stronger, and then I probably want to have higher details there and more details, and then it's kind of annoys me if I have a too.
And then you need to sell and buy a new one.
Yeah, I would rather get a good enough to kind of have a good feeling that it's not the bottleneck.
Let's move to the next technical word term that we see often and more often in the past months with all the new brands and all the new products. They are all talking about cogging.
Yeah.
Is it, first, what is it, and is it that bad?
Yeah.
Is it something, because we can hear some people saying that, you can feel cogging when the base is off, but then when it's on, it doesn't matter anymore. What's your vision about that?
Yeah, that's definitely the thing is, the cogging is the torque that you can feel from the motor.
Yeah, the steps.
The steps, the magnetic steps. In some motors, it's very smooth. There's pretty much zero cogging torque, like here. But in some motors, it's kind of more pronounced. Like here, you can feel the steps. It kind of stops and
like stairs.
Yeah, stairs, like a steps there. You can try it.
Yeah,
compare the smoothness of the motor.
This is really like buttery, and here, you can feel the steps. So how does it affect the experience of the user in real life when because some people, as I said, say, but then the software is doing compensation, so it doesn't matter. Is it true? Does it matter or not?
the software can pretty much compensate this when the power is on, if this compensation is fast enough. I'm not sure if they can compensate it completely. It can also depend on how fast you are turning the wheel, because the compensation algorithm has this bandwidth limit. It cannot compensate very, very fast torque ripple, but it can compensate the ripple when you are moving slowly. So when you power on, you will probably lose the cogging, but at the rapid speed, you might still get this.
Or some type of effects. Like in my experience, the base with the most cogging, when you are driving, as you say, normal driving might be okay, but for example, in rumble strip or some a bit hard effect, they feel more harsh, more not so smooth. Like the rumbles don't feel that smooth. Is it because of cogging or something else?
Hard to say. I would have to test it myself to say what it is, but it might be. But it might be something else. It's really hard to say. But if the cogging torque compensation algorithm is very, very fast and well made, I think it would be safe to assume that it's not an issue. But I'm not sure how the other brands do it. So it's hard to say.
It's more marketing way to sell the new products for this brand, maybe.
I don't know. One thing is sure, that the cogging of the motor is also like caused by cost savings. Bigger motor has more iron and better design internally, and has naturally zero cogging. But when you have a smaller motor that is cost optimized, cost less money, less material, then it tends to have more cogging torque, and then you need this algorithm to fix it. But if the algorithm is very good, then it's fine. But not sure how the other brands are doing it.
Next word, big word, encoder. We see that also coming at some point. Few years back, nobody really mentioned encoders, and nowadays every brand is saying, "Yeah, we move from 18 to 21, 21 to 23." What is encoder? What is the purpose of the encoder, and why is it so important?
Yeah, I will actually show you a few encoders here. These are the components that we are talking about. These are the encoders actually. So encoder is angle sensor. So is this a small sensor that is in the back of the motor, normally attached to the shaft of the motor, somehow like that. So it will sense the position or the angle of the motor. And the more resolution you have here, the more accurately you can measure the angle. The number of bits there means number of steps you can measure. And of course, more is better, at least in theory. But it depends also how you utilize that resolution. Sometimes it's just bits without getting any value, and certainly beyond some number of bits, it's not useful.
The software need to really use that.
It needs to. I can draw another picture here. Let's draw again this some kind of graph. So let's draw a position sensor output. If the number of bits or resolution would be very low, it would be like a staircase, because this is the output of very low or too low. There's like a 1, 2, 3, 4, 5 counts of angle. But if you have a high resolution encoder, then you have a much finer, much more details there. And if you have very high resolution, then you have smooth curve that you can sense. So this is the resolution, and this is like when you turn the wheel.
So it's not about what we feel, because I see that often in Discord or different social networks, like we cannot feel so many steps, like 21 or 23 bit is like billions of steps.
Yeah.
We cannot feel that. It's not about that.
Yeah.
It's about the engine control.
Yeah, there's definitely
A misconception about that, I think.
There's one thing that benefits high resolution, and it's calculation of velocity and acceleration out of this curve. Because when you calculate velocity out of this curve, you will need to kind of calculate the difference between two steps. And when you calculate acceleration of this, you need to calculate difference from two velocity steps. So it kind of amplifies the error when you have a low resolution encoder. And if we draw a acceleration curve here, it really can get really rough curve when the encoder resolution is
and then
low.
the force feedback will feel harsh. I come back to my harsh feeling.
There's two things that can happen. It can feel harsh, or it has to be filtered in the software that it feels smooth. But if you filter it so that it's smooth, then you lose the details. Because it kind of gets low pass filter. You get high frequency.
So encoder, bottom line, is really important for, it's not the only criteria, but is a must-have to get details.
Yeah, it needs to be good enough, let's say. But let's say like after 20 bits, I think it's probably not so useful. After 20 bits, I would say it's kind of good enough.
Okay. That
to me, but of course, maybe somebody can feel more.
Yeah, at some point it doesn't make sense to make a 50 bits. It will just be marketing.
It's probably just like adding megapixels to the camera and not getting any better pictures.
Okay. But in your opinion, so 2021 is the minimum to get the maximum of the motor?
Yeah, in my own experience, 20 is like getting good enough. 21, 22, but like 24 is probably gonna lose meaning after that. Okay. But there's other things in encoders also that matter. Some encoders are optical and some are magnetic. And this is...
That was my next question. Thank you.
All right, but there are different ways to build encoders. And this is also like matter of cost. Optical ones are more expensive and complex because they have an optical sensor and maybe a laser inside. And the magnetic, it's just a magnet and a magnet sensor. And they are like simple PCB and few components, very, very cheap. And the opticals one tend to be industrial components that are very precise and fast.
So it's about precision or about accuracy or about reliability in time? Maybe magnet can be a bit disturbed, or is it something like that?
I think reliability is not different, but the main difference is precision. Magnetic tend to have more like distortion or error when you measure the angle. And second thing is that they have a latency. They have naturally quite much more noise coming out of the sensor signal. So they have to be filtered to feel smooth. And when you filter it down, you will lose the speed or the responsiveness. So optical is very, very fast and accurate at same time.
So for you, it's maybe even more important than the figures itself, than the number.
Yeah.
And
I see many. We have tested many magnetic encoders that kind of advertise high number of bits, but when you test it or measure it, you can see that it's actually quite low resolution, but it's been done by filtering the signal so much that it kind of gives more bits. But it's kind of, the problem is that it's a slow response. When you turn very fast, it kind of gets behind.
But not so many. All the brands communicate about the number, but not so many about the type of encoder.
Yeah.
So
Yeah.
obviously Simucube.
Yeah, the optical is definitely the industrial golden standard when you need accuracy, and precision, and speed. Slew rate is the amount of torque that can change in certain amount of time. So, for example, we can have a 5 Newton meters per millisecond rating. It means that the torque can be changed 5 Newton meters in time span of 1 millisecond. But if this is like 1 Newton meter per millisecond, it can turn 1 Newton meter per millisecond. So it's kind of, it's basically defines how fast and how fast spikes you can torque you versus time. So we have again this game signal. Let's draw something there. It can be like this when you're driving. And if slew rate is good enough, the motor will follow this just fine. There's no lag or anything. It just beautifully follows. But if this slew rate is reduced, the motor has problem following the fast changes, like this almost vertical lines.
Yeah.
So it kind of gets behind, and then it catches up, and then it gets behind, and again behind, and then it finally reaches it, that then it can also get behind here, like follow this curve. It should go here, but it cannot. So slew rate is how fast you can change the torque. And again, it reaches here what it should be, and then again goes here and gets behind.
Okay. So the impact for the user is about the details, or even worse, that you will have some lag in the information. Like if you have to catch the back end of the car is moving, and if you don't have enough slew rate, you will not feel that.
That's possible, yeah. That's possible. You will. It's similar thing compared to this clipping, but in different way. It's kind of clipping the details.
Okay.
So, but some people actually prefer to have a reduced.
Yeah, to have a smoother.
Just to get the smoother feeling. But I think like competitive racers probably like it fast.
Yeah, so to have all the details.
Yeah, they get all the details in all the scenarios.
But these figures, we don't see the brands communicate really that much. It seems to be very important, and everybody talking about torque, about encoders, but slew rate, it's sometimes and often hard to find those actual figures, especially on the middle or low range.
Yeah, I don't know. Maybe they don't want to specify it just to, maybe they are not so good numbers that they have. So I don't know. It also depends on the cost. When you have a high power supply, high power motor, and heavy motor,
usually slew rates come with bigger, more powerful motor. If you have, it's difficult to have high slew rate with a small.
It kind of gets. It's also like cost thing. When you have reduce the cost of the motor and power supply, you will probably have to compromise also on that.
Let me know what you think about refresh rate. How does it work, and how does it affect the force feedback?
Yeah, the refresh rate, I think we can separate this to 2 different refresh rates. There's the game refresh rate, that the game will control the motor, and then there's internal refresh rate of this wheelbase. And the game refresh rate is typically from 60 Hz to 400 Hz range, and the internal refresh rate is typically few kilohertz at least. So, and this is just because the USB and the game engines, they don't have this high real-time hardware, but this wheelbases, the electronics have a high real-time electricity. They can easily manage higher refresh rates, but that's good. It helps motor to kind of do filtering and
Okay. You can add more prediction or filters or
yeah. The filters will feel more natural and smoother and better. For example, this damping and friction and such filtering work better when the refresh rate of the wheelbase is higher internally.
Okay.
And of course, the game refresh rate is also positively affecting the details, amount of details. For example, 60 hertz is kind of quite low. You cannot feel the fine details of the road when you are driving. But if you have 400 hertz, you can get much more small details, high frequency details on the road.
Let's move to software then, because we talk a lot about hardware, but software is almost as important, maybe even more important. What do you think?
I would say it's equally important. It's like if you have a chain link, it's a weakest link. It could be software or hardware. So they both must be.
Yeah, no point to have the best engine, the best encoder.
Yeah.
If you don't have the proper software to manage it.
Exactly.
Okay.
And the other way also, you cannot get good output with just good software alone.
So thinking about software, obviously we'll talk just after about filters. You mentioned dumping and things like that, but there is a mystical word that is coming up, is the algorithm, because the game is sending information, but you have your software need to translate that. So is it the algorithm job? And how is it different from one brand to another? It's a bit technical for me, but I'm really interested on this one.
Yeah, the algorithm definitely plays a role. For instance, there's one thing that seems to be in marketing is, again, I will try draw once again this torque versus time. Torque versus time, and in marketing you will see that some brands are communicating about the step response when the torque is suddenly changed, like sharp edge, from 0 to certain number of Newton meters. And what happens with bad algorithm or bad hardware is that it overshoots. It will kind of, the actual torque might be like that. It should go like this step, simple, straightforward, but it might actually get this ringing and then stabilize afterwards. Or it might be a slow response. It can kind of get slowly in the target. But we have noticed that the control algorithm is very critical here. But when the algorithm is finely tuned and well made, it will very rapidly follow the step and there is no overshoot. But some brands actually kind of have this kind of pictures, and it's just a sign of bad design if there's this kind of behavior. We pay extra careful attention to have this kind of fast response and no overshoot.
Trying to translate that into user experience, is it when we feel like we say it's robotic or less natural? Is it related to that? Or
it might be, but there are many things in software. One thing is also like how the filtering or smoothing is done, like reconstruction filters or smoothness filters. There are countless ways to do it, and it's of course hard to say which is best, but certainly they are different.
Okay.
So the problem here is, let's talk about this refresh rate a little bit. Again, this graph, I can show the same thing. Let's see that game output rate is low. It looks like this. So this is the torque from the game. Let's say it's 60 hertz. So each part is like 16 milliseconds time, and that's 60 hertz, right? And that would feel very rough If we just produce this with the motor, it would be making lots of noise and
So the algorithm need to
smooth
that.
Yeah, it should kind of make it smoother, and it depends on the algorithm how well it does it. If the algorithm is good, it actually follows this average line
without additional spikes.
Yeah, in ideal case, it would kind of figure out what is the.
So that's a good algorithm.
Yeah, but if the algorithm is bad, it could be kind of causing delay. It could be following the curve, but with the delay. So that would feel like
you're too late to catch the car.
Yeah, I think it probably might affect that, but it might also feel like gummy feeling or like a somehow rubbery feeling.
Okay.
It's not like a real car. It's like a somehow like weird.
So you lose the benefits. We dropped the belts and we had a software belt.
Yeah, it kind of feels like rubbery, but this can also happen with like if the encoder is bad and you need to filter it out and you cause the delay there.
Okay.
It can happen in hardware and software.
Let's go to filters now. What the user, because algorithm is decided by you, but then you let us some room to tweak that. The filters. What is the correct way to start? Because I always do, because I compare base, I test base, but so I always try to use no filters to have the raw feeling of each base to compare. But what is the correct way? Or it depends on the game, or what is your vision about that?
Yeah, also I like it. Actually, in ideal world, there would be no filters, and that would just require that the game would deliver.
Yeah, should be the game that giving you the exact
the game that gives the command, torque command. But if the refresh rate of the game is low and it lacks filters, it kind of lacks some details that needs to be there, then the wheelbase will kind of compensate that by having your filters that you can adjust.
Okay.
In real life, you need to have at least some kind of filter to reduce the roughness of the game.
A little bit of damping.
Yeah, damping also. The damping is different thing. There's this signal filter. Let's call it reconstruction filter. This is what I definitely would have. I would adjust it so that it feels silent enough for me, and on opposite side it would be fast enough. So it's kind of finding a good balance, how fast it must be and how rough or smooth I want it. So find a sweet spot there.
And depends of the game also.
Yeah, it depends on the game.
Some game have more quiet FFB like iRacing, and some other like Le Mans Ultimate. They are very, very maybe sometimes too much information. So this is where filters can be important.
Yeah, definitely. Also, the game refresh rate is kind of quite big factor here. For example, 60 Hz is quite rough unless you filter it down. But if you have 400 Hz from the game, it can be quite good and smooth without much filtering.
Okay.
And the other things like damping and frictions, they are like static filters, and it just makes the static. It's kind of friction. It's like it's stable, but you need to use certain amount of force to turn it, and the damping in also like it makes it more like a viscous damp. It feels like a smooth. But those are not filtering the game signal. They are just changing the feeling of the general behavior of the wheel.
Bottom line, it's better to start with 0 or low filters and just adjust to your personal taste.
Yeah, I would do that. I would start from low and then just add just enough filtering. I would keep it as transparent.
Sometimes I see people with 30% damping or 30% friction. For me, it's way too enough.
Yeah, some people might like it that way. I normally like to have also some damping and some friction, just to have a more like a stable. If I take my hands off, it doesn't start
it doesn't shake.
shaking. And also, if you drive a real car, it has friction, it has damping.
Yeah.
So it kind of also
You had that. Okay.
yeah, you have that there also. So it's not like artificial or bad thing.
Okay. I have one very important question, because this one I have my ID, but maybe I'm completely wrong for many years. I always say that it's better to put the maximum torque in the software, the power of the base, and then to adjust the gain in the game. But some people do otherwise. What is the correct way to do it?
Yeah, I think I would talk about this clipping thing. It's if you limit the torque of wheelbase and
you introduce clipping.
Yeah, you might introduce clipping, but if you set maximum torque in the wheelbase and then just adjust the game torque, you probably avoid clipping easier. But of course, it doesn't. As long as you don't get clipping, it's fine. It doesn't matter which way you set it.
Okay.
The clipping is the issue. If you can avoid that, then you can have a 50% torque on the wheelbase and no clipping, because the game doesn't ask more than you want it to produce. But to be safe, you can add more torque in the wheelbase and then reduce the game torque. Then you have no clipping.
Okay.
Probably.
You don't. Maybe some people will say, like, if we put 100% with a very, very powerful base, so you have to limit the gain in the game.
Yeah.
So maybe you will send less information, less details, maybe, or is it totally stupid what I'm saying?
The details are not lost that way. The details are lost in clipping. So if you have set wheelbase to produce 10 Newton meters, and then game wants to produce 15 Newton meters, then you will get clipping, because you can get only 10 out of it. But if you set wheelbase to 20 Newton meters and game wants to output 15 Newton meters based on your setting, that's the maximum. You get 15 Newton meters. You have 5 Newton meters headroom there, but you don't use it. But
I was not wrong, so it's better to put the maximum of the base in the software.
It doesn't need to be maximum. It's I would have some headroom, like a few Newton meters more in the wheelbase that you actually are using. So it's kind of safe enough. And it's actually my preference also to have some limit on the wheelbase. I don't want to put maximum torque on the wheelbase, just to have some clipping in emergency case. If I crash the car, I don't want to have this brutal effect.
Avoid to break your thumb.
Yeah, I would. Then in that case, I would love to have this clipping happening, just safety.
Good one. Let's go back to hardware, but outside of the motor. Obviously, a very important part is the quick release, because it needs to translate towards the wheel. So in the middle, we have this bit. How is it important for you? Is it something critical?
Yeah, of course. This is the interface from motor to wheel, and how I would like it is that it's rigid and solid. When you put the wheel on, it will do its job. It's like in ideal case, it's completely like a solid shaft. There is no quick release. But in perfect quick release, it doesn't matter, because there's no flex. It doesn't give anything disturbing effects there. So this is important. For example, if this is too weak, it's made from plastic and it's small, then you probably have some flex, and it feels like for me it feels like a low quality or something. But I like it hard.
You lose if you have some play, you will lose the benefit of all the details, and you will get.
You might get the details true, but it feels like a toy. It's not like a real car. It's like a. In real car, you don't kind of have a wheel that will flex, or you have to be careful not to break it. And also I like it silent, because when you attach it securely, it doesn't get generated.
Clack.
Yeah.
Obviously, the wheel has an important role in the way you feel, because of the size, because of the weight distribution. But is it also something on the quick release? If the quick release is lighter, smaller, lighter, is it better? Does it help, for example, a smaller base? If the quick release is lighter, does it help, or only the wheel size matter?
We are talking about mass and basically the inertia.
Yeah.
If the quick release is big and heavy, it has more inertia. But it's probably still quite small compared to the inertia of the wheel and the motor. So I would say that this is not so critical. It can be big and metallic part, and it doesn't help to get smaller and lighter, because the wheel and the motor will be dominating the inertia anyway. So I would rather have a solid.
Yeah, for sure.
Yeah.
But at equal rigidity, you think the impact is not so big, because the weight is really centered, so low inertia, right?
Yeah, right. That's right. The inertia is heavily affected by the diameter. So if this is like too big, then of course it feels heavy. It feels more inertia, but in this size, it's no problem. It can be. This is like maybe 5% of the total inertia of the system. So it's
the impact is really low.
And also, there's no point of having zero inertia, because real cars have also inertia. If you want realism, you want some inertia also.
Okay. If we go a little bit wider, obviously we need to play not on this table, but on a rig. How important is it? Obviously it is, but give us your vision about the rig and how it can emphasize the quality of the force feedback, or the other way it can destroy the benefit of the...
Yeah, this is actually quite important. I think the rig should be non-flexing also. It should be like quite stiff, and also like have a low resonance tendency. If you have a flexing rig, of course it feels like it's not real car, because it's kind of feels like toy or weak. And also this weakness can translate or cause resonance. So it can vibrate when the wheelbase is generating fast response. It can actually cause also the wheel to vibrate. I have seen rigs that will kind of start making noise, high-pitched noise, because the frame will resonate.
Okay.
So I would like to have a quite solid construction of the rig to not resonate and not flex.
So guys, invest on the rig. Very important, even before, actually. Maybe it's better to have a lower end base on a better rig than the opposite.
Yeah, I think it's also like balance.
Yeah.
I would not go all in the rig and ignore the rest. It's balanced, but I think it's no problem, because you can find very good rigs at quite good price.
The market is really wide in terms of...
It's like 300 euros and you get very solid rig.
I think balance is a proper word. This question might be a bit tricky, but does it help you to be a better driver if you have a better gear? This question rises a lot. Some people say, no, we are very, very fast driver playing on Logitech G25. But come on.
Yeah, what we hear here is that at least these motorsports people who practice, they tend to say that it plays quite important role to have a high quality force feedback, and that's why they actually use active pedal also, and also like Simucube Ultimate model to get the maximum performance, because they just say that it helps them to practice better and get faster. But for average users, I think they don't need the maximum performance, but definitely it doesn't hurt. It will help, but maybe it's not worth the money to kind of put ultimate level.
Once again, go to a balanced setup compared to your expectation and your budget for sure. But
but nowadays you can actually find quite good wheelbases with low budget also. But then again, these differences are these: how good encoder, how good algorithms, how good motor there is, how much is the flipping, or
it starts to be very, very complex. That's why I wanted to have this video, and thank you so much for that, because it starts to get very technical year after year, and now it's with a lot of choices, so it's hard for the end user, for the sim racer, to choose between all these
it's
claims.
It's a complex topic, and definitely I agree that how these are marketed, it's kind of missing lots of details, and in the end it's what you want. It's hard to say before you try it. You compare yourself, and when you try it, you might someday notice the difference, but in the beginning, when you are a beginner, you might not notice the difference between different qualities of feedback.
So that's why maybe it's better to go step by step and improve.
I would definitely myself kind of make safe investment if I'm serious to racing. But if I don't know whether I even like sim racing, then I would probably take some low budget hardware and then upgrade it later if I want to continue the hobby. But if I'm motorsport driver, I definitely would look from the high end then directly, because
it's been different expectation, different purpose.
Just because we know that the motorsport racers say that it helps them to practice better when the thing works best.
What makes Simucube special? So compared to the other, why do you stand out that much? You are the benchmark, so why that?
I think our probably core values are the transparency. It's like clear window to the simulation of the physics of the simulator. So there's no need to have filtering because of bad hardware or the software is limited or whatever. So we provide this accuracy and precision that is needed, and also consistency. When you want to practice, you want to know the system so well that it actually feels like you become one with the simulator. In ideal case, you don't notice that you are in the simulator, and that means that you practice it so well, and it means that the system should not change. For example, the hardware should not degrade and feel different after
one lap after another.
For example, the pedals are the problem. If the pedal is like made from rubber dampers, it can feel different over time, and you will kind of lose the muscle memory. And it's then important to have this consistency. You can always rely on that. It will stay same, and then you can become one with the vehicle. And that's very important when you want to master the racing.
And final word, because you already are at the top of the range, how can you improve for the future? What's your vision for the future? What do you want to improve even more? What can you improve even more?
That's the challenge, because in Simucube 2 we already did quite good job, I think, and it's been introduced 2019, and it's still the
king.
reference. Of course, we can add some features. For example, we could add something here in the quick release. that will transfer the data and power to the wheel. That's one thing. We see potential there. And of course, we could also remove the USB. USB is
USB is often a source of troubles.
Yeah, it's often source of the troubles because USB has not been designed for this kind of high power motors. It's been designed for mouses and keyboards and USB memory sticks and stuff like that. It works there very well, but in simulators, it starts to break down when you have many things in quite large system. So USB is sometimes problem that we can eliminate.
Okay, I think we covered it up. Thank you, Tero, so much for this long time for us to cover all the technical information about direct drive, and very excited for the future.
All right.
Thank you.
Thank you.
Thank you so much.
Thank you.